Remember, you're going to write the final examination and trig is in paper 2. You're going to find it very interesting if you revise it now and there. So like looking at these questions, when we created these questions, there were too many trigonometric questions. So it became question number 12 instead of 5 and 6. And I said to you at the beginning, these questions are usually in 5 and 6. So don't be surprised if you see it being question number 12. Just that there's a bunch of many questions from previous question papers, and this was allocated to number 12. So in this question, this is what was given to us. Let's look at it. It's still on the proofs, so it's written in question number 12 for the pamphlet that we are using. Okay, in question number 12.1, they said, prove that this can only be proved if the denominator is not equal to 0. So they have explained to that this cos alpha minus x cannot be 0. So let's write the question down. This is 12.1. They said sine of x plus 450 degrees minus alpha divide by cos of alpha minus x equals 1. So we must prove that if the cos of alpha minus x is not equal to 0, then the left-hand side is equal to the right-hand side. In other words, this whole statement will give us 1. So you need to be a little bit creative to do that logic. Let's see. To start with, here we are not used to start with letters. So we need to rearrange this one, take this and put it at the beginning so we can be able to do this logic. Okay, let's see. Let's choose our left-hand side because it's complicated. This is equals to sine of x plus 450 degrees minus alpha. And our denominator, therefore, it is just cos of alpha minus x. Let's play around with the numerator until we can get something that looks like a denominator such that it can cancel. That is the logic behind this. Now, first we have to interchange this so that we can be able to arrange. Let's do that. So it's sine of 450 degrees. Which one do we want to start with? Alpha. Why? So that we accommodate our denominator. So it's minus alpha plus x all divided by cos of alpha minus x. Folks, make sure that your divisions are written and are visible. You don't need a ruler for that. Just put a line to save time and then the marker can see what you are trying to say. Now let's write it in this manner. This is sine of 450. If we take out the common factor of a negative there, we will left with, so let's use a square bracket for this one. We will left with an alpha minus x. We are going there. Can you see? We have that alpha minus x now. So, but we need to work it out until it gives us what we want. So that is alpha minus x. Okay. Continuing, 450, how do we get it? We need to say 360 plus something. Remember, we don't have an angle that is just 450. We must reduce it from something. So we are going to have sine of two numbers that when we add them together can give us 450. So that one will be 360 plus a 90. If I say 360 plus 90, I will definitely get there 450. But this 90 must have this angle alpha minus x on it. Okay, and we have to divide this by the cos of alpha minus x. Folks, if you look at this properly, you can say that because of plus, I can simply put a bracket there. That will make my angle 90 minus alpha minus x in that particular bracket. So if this was theta, we'll say 90 minus theta. But now we have alpha and minus x as our theta. So you substitute that in that manner. So 360 plus is on the first quadrant for which all ratios are positive. So even sine is going to be positive. Therefore, we're going to write it as sine of 90 minus alpha minus x. And we divide that by cos of alpha minus x. Remember I said sine is the wife while cosine is the husband. So in this case, we have a sine and we are in 90. It means that we have to use the husband, which is a cos. But we have to look at which quadrant are we. 90 minus is in the first quadrant. All ratios are positive. So it means this is going to be positive cos, not sine anymore, because if it's a wife, sine, and then we put a husband cos just because of a 90. There's 90, you always interchange the cos and the sine. So this is going to be cos of alpha minus x, which we divided by the cos of alpha minus x. Voila, we are in the same thing now. Then we can cancel them. These two will give us what? A 1, which is our right hand side. It just need a logic for you to go through that correctly. If you practice more, you will actually get it right. Okay. We have one question that we need to continue with. It's in 12.2. This one is not the proving, but it's a general solution. Now, in general solution, this one, they strictly told you that this is a general solution. Normally, they don't tell you. They'll just say solve for theta, solve for x, and so on and so on. You need to be able to figure out how to solve for that. So this one, it is 12.2, and then we are doing the general form. They say determine the general solution of, and they give us cos 2x equals 1 minus 3 cos x. Folks, they're all cos. There's cos x there, but there's cos 2x. So it means we have to change the cos 2x and make it something that has to do with x, because 2x is not the same as x. That need you to go to your formula sheet and then find out what cos 2x in terms of cos can be. And that will be 2 cos. So in my, it's going to be 2 cos squared x equals 1 minus 3 cos x. So now you have cos throughout. You can be able to put them in the same side. There's a square, so it's quadratic. You can be able to factorize. So let's put them all in the left, and then we can be able to factorize. Okay, this will be my plus 3 cos x minus 1 equals 0. And if we can factorize, remember, we need to factorize such that we can be able to get, okay, this is cos squared x minus 1 equals 1. Okay, so the minus 1 there would go that side, makes this one a minus 2. If you factorize them, we'll get 2 cos x, and there we'll have a cos x. If we multiply the 2 with the 2, we'll get to what we're looking for, which is 4. Subtracting it from 1, we'll get the 3, but we need to put the signs in between. So that is cos x is equals to a half, or cos x is equals to a minus 2. This one is not a solution because we cannot get an angle with a negative in terms of cos. So we're going to focus on this one. For general solution, we're going to say x equals to arc cos, which will give you cos to the minus 1 of 1 over 2 in your calculator, and this will be 60. Now 60 became your reference angle. Now if that's the reference angle, you're going to say x is equals to 60 degrees plus. We are talking about cos, so it's going to be 360 degrees k, where k is an element of integers. Now k can be any number that is integers from negative to positive numbers, including the 0. You go on and put 1 and put 1 and put 1. And some textbook will go on and say, because we said this is in the first quadrant, you can go in the fourth quadrant and also use 360 minus, for which is actually covered here. But if you write it, no one can penalize you. So it will give you 300 plus 360 degrees k, where k is an element of integers, because 360 minus 60 will actually give you a 300. So practically this is how you do the general solution if there's no boundaries given to you. Sometimes they'll give you a boundary, so you must deal with the boundary and get all those ones that they're telling you. Matrix, this is very simple questions that you just have to practice more and more and more until you get it right. Okay, thank you. Okay, Matrix, we're still doing that question 12 that we're talking about, but usually in your question paper is going to be question 6. So that question that we just did now for general solution is 7 marks. Can you see 7 marks? It was very free for you to get it. Now let's go to this 12.13. In question 12.13, this is what we are going to get. Let's see, 12.3. 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, 12.3, which is 12.3.1. They said prove that, so we are doing too much of proof here. For angles A and B, obviously the left side must be equal to the right side. So let's write what they've given us. This is sine A divided by sine B minus cos A divided by cos B must be equal to 2 sine A minus B divided by sine 2B. Remember, angle A and angle B, they are not the same. So you must try and make sure that you put that in mind. Left side must be equal to right hand side. So let's pick whichever. I'm left-handed, so left is fine for me. I'll pick the left one because it's complicated. You can pick the right one, it's fine. So let's start with the left side. So my left-hand side is equals to sine A divided by sine B. Remember, guys, to recopy the statement so that when you make mistakes, we can be able to follow them. So copy it as you see it. So this is what we have. Okay, interesting. We have to look at the denominator first. So our denominators are sine B cos B, for which when we have our numerators, remember we said this denominator divided by that denominator, we're left with cos B. So this is sine A, which is remaining there, and the cos B from the denominator, minus, the same applies, the denominator divided by this denominator, we're left with sine B, and multiply there, we'll have cos A sine B. If you look at this one, folks, it's similarly to what you have in your formula sheet. Go to the formula sheet, you'll see something like that. And this is the compound angle for sine. So this is sine A minus B divided by sine B cos B. Now, so far, this is what you have. And one will say, but I'm having sine B cos B, and there I'm having 2, and I can't deal with it. It is not that difficult, guys. If we go back to our formula sheet, let's just write it as rough somewhere. If we go back to our formula sheet, we will find that sine 2 of a same angle, in this case, we are talking about B, because I want to do this one. It's actually equals to 2 sine B cos B. Now, if I want sine B cos B to be the subject of the formula in this compound angle, in this double angle, I must divide both sides by 2. So if I divide this side by 2 and that side by 2, there 2 will cancel and I'm left with sine B cos B, which is what I'm having there by the denominator. But this can be equals to 1 over 2 sine 2B. So it means instead of writing sine B cos B, I am going to write half sine 2B. So that's what we are going to do there. This is sine A minus B divided by half sine 2B. Now, if we are having half sine 2B, we already have our 2B, that's what we want. We are left with the 2. This is division. If we flip and times, the 2 is actually going to go up. So if that's the case, then it means that we'll have 2 sine A minus B divided by sine 2B. Voila, that is equals to our right hand side. And you are done answering your question. As simple as that. What you need to do is to focus on what you know and how can you relate it with what is given to you. And that's how we prove the left-hand side and the right-hand side information. Okay, folks. If we go to the second question, it is 12.13.2. Similarly, 12.3.2, I mean to say. It is a similar question, but you need to apply different content. But your formula is still important. So let's copy it down so that we can be able to talk about it. Sine 5B divided by sine B. One is saying, 5B. I have never seen that. But it's really simple. Just have to keep calm and focus. This is cos 5b divided by cos b. That must be equal to, let me write it down here. It must be equals to 4 cos of 2b. So we can choose whichever side as well. The left side is more complicated because it has 5 and so on. So I'm going to choose that because I see it's the one complicated. My left hand side, it's equals to sine 5b divided by sine b minus cos 5b divided by cos b. If you look at it, we are doing similarly to what we just have done now. Doing this, we're going to find our lowest common denominators first. It's going to be sine b cos b. There we will have cos b multiplied by sine 5b minus sine b multiplied by cos 5b. Still, if we look at this, it's the reverse of the compound angle of sine. So we need to take it back. How do we take it back? We just say this is sine of 5b minus b. Divide all this by sine b cos b. Now, what is 5b minus b? Remember, b is the same angle in this case, so it's going to give us 4b. So it means we are going to have sine of 4b divided by sine b cos b. We are kindly somewhere there because we have 4, so it's making us feel happy. But it doesn't really give us what we want. So having this 4, we're going to do what? We are going to expand this. Remember, 4b can be rewritten as 2 times 2b. So we are going to rewrite that like that, as 2 times 2b. If we rewrite this as 2 times 2b, it means we are having a double angle of sine with 2b, not b. So we are going to write it just below. So this is the same as 2 sine 2b cos 2b. That's what it means. Okay, and after that, remember we said sine b cos b can be written as half sine 2b on the previous question. So that's what we are going to use here to substitute as we did. So we're going to say this is divided by half sine 2b. Now we are multiplying now and we are dividing. So that means that sine 2b can actually cancel with the sine 2b. And we have 1. Now we have 2 divided by half. If we flip and times, that will give us a 4. And now it means we are having this 4 that we have there. Multiply that 4 with the cos 2b, and that will give us our solution. Let's see if we can write it there and if it can be visible. So we have 2 multiplied by 2 over 1 multiplied by cos 2b. And now that gives us our solution as 4 cos 2b, which is our right-hand side. Okay, then you have answered the question, and that's what they wanted you to do. It's logic and need practice. It's not that much challenging because it's about 3 marks to get. So you can get it right if you practice more. Okay, matrix, we're still doing these proofs. I said to you, you must make sure that you practice a lot and then you'll get it through. It's just logic. So now there's another question that was extracted from another question 8. But this question, it is still on what we guys are doing, the proving and the general solutions and those kind of things. So let's start with it. This question was taken as 8.2 because the other part we have done them, so I didn't feel of repeating the same things afterwards. So in 8.2 we're saying, given an expression, consider this expression, 1 minus cos 2x minus sine x divided by sine 2x minus cos x. And after given that expression, we must prove something on it. This is the expression minus sine x divided by sine 2x minus cos x. Now, in 8.2.1, we were told that we need to prove that this expression will be equals to tan x. So we need to prove that our left-hand side equals the right-hand side. Again, you take the complicated side and complicate it and make sure that it gives you what you're supposed to get in another side. So in this case, our complicated side is our left-hand side. So left-hand side will be equals to 1 minus cos 2x minus sine x all divided by sine 2x minus cos x. So you need to change things such that they will give you what you are looking for. Look at it. Your tan, it sometimes consists of sine in the numerator and cos in the denominator. So try to figure this out until you get there. First of all, if we change our denominator to be 2 sine x cos x minus cos x, we can again take out the common factor of cos, then we're left with 2 sine x minus 1. Now this is what you are trying to figure out at the top. How will you do that? So first change cos to be in terms of sine. And from there, we will take it. So we have 1 minus. How do we change cos to be in terms of sine? You go to your information sheet. This is your key. In the information sheet, the cos in terms of sine will be 1 minus 2 sine squared of x minus sine x. And then you simplify. Remove the bracket. It means we will have 1 minus 1 plus 2 sine squared x minus sine x. All this will be divided by 2 sine x cos x minus cos x. Now if you look at this simplification, 1 minus 1 will give us 0, and 2 sine squared x can be rewritten as 2 sine x multiplied by sine x. So we'll take out the common factor of sine x. Then we remain with 2 times sine x minus 1. At the denominator, we are going to take out the common factor of cos x. Then we remain with 2 sine x minus 1. Can you see? The logic just happened. So the brackets now are the same. We can therefore cancel them so that they can give us 1. This bracket and that bracket, they are the same. They'll give us 1. And now this will be equals to sine x over cos x, which is the identity of tan x. Now that is equals to our right hand side. And you are done to answer that particular question. So can you see how you can go about that question and you will get it right as it is? Go on and revise, practice, practice, practice. You'll get it right. 8.2.2. They're saying the above expression is undefined if sine 2x minus cos x equals 0. Solve the equation through the interval where x is greater or equals to 0 or less or equals to 30. So your solution must lie between that. So let's do it. 8.2.2. We are told that it's undefined. So undefined is when the denominator is equals to 0. That is where undefined is. We must solve for x. Now, look at this. We have sine and cos. We just said these two are somehow married. So we can put them in that statement. So let's put sine 2x equals cos x and decide whichever you want to change it to 90 minus. Folks, we must use the angle of 90 minus because it's in the first quadrant and all ratios are positive in the first quadrant. So I will decide to change the cos. For some reason, this will be sine of 90 minus x, and that is still sine of 2x. Now, the moment we have the same ratios, we drop them and we focus on the angles. So the ratios are not important anymore. What is important is our angle. So 2x, it's going to be 90 minus x, meaning that 3x is equals to 90. Now this is our reference angle. Remember, we are looking for them in the boundaries. What is the boundaries? We are looking for them in the boundaries of sorry. We are looking for them in the boundaries of x being greater equals to 0 degrees, less equals to 360 degrees. So this is where our answers, our solution must fall within. Can be 0, can be 360. So how do we do that? We're going to use it as if we were doing general solution. We're going to say 3x is equals to 90 degrees. We are dealing with a sine, so it's going to be plus 360 degrees k, where k is an element of integers. And then we start using the calculators, put those integers inside so that we can get the 0. First, we start by putting a 1 there, we start by putting a 2 there, and go on and go on and go on. The negatives and all those values. So if I put a -1, my answer will be negative, so it's not part of the solution. If I put a -3 and so on. So first of all, let's divide everything by 3 to get x, because remember, we are solving for x. So we have to have it as x. So divide by 3, and divide that by 3, meaning the period has changed. So if we say 3x divided by 3, we remain with x, and 90 divided by 3, it's going to give us a 30, and 360 divided by 3, it's going to give us 120. So that is our new period, where k is an element of integers. Okay, now we start doing what we need to do. If I put 1 here, so one of the solutions that I have is 30. Okay, if I put 1 at k, then my solution will be 120 plus 30, which is 150. If I put 2, I'll have 240 plus 30, then I'll get 270. If I put 3, I will have 360 plus 30, which is more than the boundary. So now my solutions, therefore, is going to be 30, 150, 270. For now, those are my solutions. That is between the two boundaries from 0 to 360 degrees. And that's how you answer this kind of question. It is 4 marks, your reference angle, and your solutions will be having those marks. And that is the end of this question 8. You need to be careful and make sure that you understand when there's a boundary and when there's no boundary to answer the general solutions.